See here what they given. A current of a 0.5 ampere is drawn by a filament of an electric bulb for 10 minutes. See, just to remember, whenever you are going to see that first one, that is the ampere, you should think that, oh, ampere. What is this ampere? Ampere in the sense we are going to this is the SI unit of the current. Okay, so current I is equals to current anna ನಾವು I ಅಂತ mention ಮಾಡ್ತೇವೆ. So I is equals to 0.5 ammeter, what they given for us, and drawn by a filament. Filament in the sense in the bulb there will be a small flickering thin wire shaped structure is there, my dears. See, as you are seeing in the screen, that one will be the filament which glows, that bulb glows for the 10 minutes. 10 minutes actually we switch on that bulb. So that is the T, 10 minutes. Minutes in the sense time. So they given time also here. So what we have to find? Find the amount of electric charge that flow through the circuit. So we need to find the charge. Charge in the sense Q. Okay, we need to find out this Q. And we have the formula here, that is a I is equals to Q by T. I is equals to Q by T formula is there for us. And how to mention what we have to find out here? Q we have to find out here. So just change this to Q is equals to I into T. Okay, they given I for us, they given T for us. So we have to change our formula according to our requirement. So Q is equals to I by T, which is happens here. Same thing what they given. Q is equals to IT. I in the sense 0.5 ampere into 600 seconds. Yeah. So time they just converted to the minutes to the seconds. Why? Because when we are calculating, it should be always in the least SI units. So that's why 600 seconds. So 300 coulomb. 5 6 ja 30. So this one, what happens? 300 coulomb. And listen it carefully, when we are mentioning 300, if you only mention 300, it will be the wrong. You have to mention the coulomb. Why? Because here they asked about the charge. So if they asked about the charge, in the sense you need to mention the coulomb here. Why? Because the charge SI unit is coulomb. This is how all about the give example which is given in your textbook. And next, towards this blue questions what they given in your textbook also. The first one is, what does an electric circuit mean? In the introduction part also I told that what do you mean by the difference between electric current and the electric circuit. Here they just ask the electric circuit. So continuous closed path of electric circuit is called electric circuit. Okay, this is how the definition. And the next one is a define the unit of current. Which unit is we are going to measure by the current? That is a ampere. Ampere is the one which we are going to say the unit of the current. And next one, calculate the number of electrons constituting 1 coulomb of charge. They are just asking 1 coulomb of charge, how much 1 coulomb of charge, 1 coulomb how much charges is there, they are asking. That is how much electrons is there. If we want to say in the sense, they already given here 6 into 10 to the power of 18 electrons, which is equal, the SI unit of electric charge is coulomb, which is equivalent to the charge contained in nearly 6 into 10 to the power of 18 electrons. They given already. So that's what I wrote here. So 1 coulomb is 6 into 10 to the power of 18 electrons. I hope I made you clear. So next I am going to convey for you the problem and the blue questions which is given in the page number 96. The question hangs like this. How much work is done in moving a charge of 2 coulomb? See, in the starting question only they asked how much work is done. In the sense we need to find the W. W how much? See, moving a charge of 2 coulomb across 2 potential having a potential difference of 12 volt. See, 2 coulomb in the sense what they given? They given charge here. C is equals to 2 coulomb. And next one is across which actually this 2 coulomb is moving across the point which has a potential difference of 12 volt. So they given the potential difference also, that is a 12 volt. Okay, fine. So now we have to discuss about the formula. Which formula we have to use? We have to use the work done. See, here I have the formula for you what we discussed in the previous video. That is potential difference is equals to V is equals to W by Q. So here what we have to find out? We have to find out W here. Okay, so just change this formula according to your convenience. W is equals to V into Q. Okay, fine. See, W is equals to V into Q. What they given also for you guys. So we have that is a 12 volt, and Q also we have that is a 2 volt. So just 12 to the 24 and joule. Just observe the answer here. They didn't kept only the 24. They kept joule. Joule, why joule? The SI unit of the work is joule. So they just kept as a W is equals to 24 joule. Clear? And the next one is the blue questions. The first question, name a device that helps to maintain a potential difference across a conductor. So what is the device which the potential difference we are going to measure? That is a voltmeter. Previous I showed with the picture also. If you didn't have a look towards that, just have a look towards the previous video. You will going to get the answer. And the next one is, what is meant by saying that the potential difference between 2 points is 1 volt? See what they are saying, if between 2 points, the potential difference is 1 volt, in the sense, what they want to say for us. What about the joule and what about the coulomb they are asking? Just have a look here, glance it once. See, 1 volt is equals to 1 joule coulomb inverse, in the sense we can write this as this one also. 1 volt is equals to 1 joule by 1 coulomb. So what they are saying, if 1 volt is there across the end of the two wire, then the 1 joule is work done here with the 1 coulomb of the charges, what they are saying. So the answer is 1 volt is equals to 1 joule by 1 coulomb inverse. Only 1 coulomb. If we want to write this beside of the joule, then only the coulomb inverse will come. If we wrote in the denominator, only coulomb is enough for here. Clear? Next one. The how much energy is given to each coulomb to charge passing through a 6 volt battery? So what the question says is, if we are passing 6 volt battery, and how much actually the coulomb of charge we have to pass? For the same question, same reason, what we have the above answer. See what they are asking here. Just have a look towards this. 1 volt is equals to 1 joule. So if we wrote 3 is equals to 3 joule. If we wrote 4 is equals to 4 joule. Okay, fine. So here what is the question? We have the 6 volt. How much coulombs of charge actually, or energy in the sense joule here? So both we have to find. So 6 joule or the coulomb. This is the answer. Okay, I hope I made you clear. Thank you so much.